Thank you for joining. We'll be getting started in a little bit. Just gonna check a few things here, but please let me know if you're able to hear me in the chat. Thank you. Hello all, and thank you for joining our webinar today. Appreciate you all joining. This is another exciting topic for us in our series of webinars that we do here at Water Analytics. Have a little fun with this one of analyze this and control that. And really what we want to start to walk through is choosing the right Aquametrix solution for you and understanding the different technologies that are out there and what may be applicable. So as we go through this, feel free to add any questions at any point into the question section or into the chat, and we'll have some time for questions and answers at the end of this presentation. So again, really what we want to dive into here is about control, right? You need more than just measurement when it comes to water quality. You need that control to be able to help you achieve that water quality. There's a lot of different options out there in the industry today, and not all of them are the right option, right? And that's what we want to walk through a little bit today, or what are the different options that exist out there, and then talk about how the products here at Water Analytics are able to help you achieve some of those solutions. So as we go here, just using the features within Teams, if you guys don't mind raising your hand, if you are familiar with the differences between indicators, analyzers, transmitters, controllers, and this is more of a refresher for you. So I see a few hands here, so that's good. But it looks like the majority, this is a bit more novel. So I appreciate that. So I want to start off with then, what are the big differences? And I tried to simplify this into really simple terms with saying, with an indicator, right, it's showing you a value, right? So as I call it here, it's A, right? A value is going into that display, into that device, and you're able to see what that is. So in this example here, it's 7.21 pH. You know that, you can see that, and it's telling you that information. And then you have your transmitter. And what that's doing, right, is taking that information in. It may be displaying it, or maybe a blind transmitter and just simply relaying it out. But it's taking that value from a sensor, and then it's sending it to somewhere else, right? So with the indicator, it's taking the value from the sensor, and it's staying right there within that device. And then you have your analyzer, and that's taking that value from the sensor, and it's converting it into a different number. So that may be, it may get the raw millivolt input from a sensor, and it's converting that into something meaningful like pH. When you start to look at indicators, transmitters, and analyzers, they all do have some overlap and blend across each other. Right? So you may have an indicator that's also just simply an analyzer. And you may have a transmitter that's also an analyzer. But then you get to the last part of this bucket, and that becomes the controller, right? It's going to take that value from whatever, if it's a raw state or a constant, right? So it's going to be a milliamp, and it's telling you what that value is, and that's the A to B conversion. But then we bring in C, right? C ends up being right that control. It's sending a signal to other areas, and that becomes that third layer with it. And that's a very simplified view of what a controller's kind of differences are. When we get into it, there's going to be a lot of different types of controllers, going from kind of the very simple basic controllers all the way up to, if you think about it, a SCADA system, which is taking information in, it's analyzing it, and then it's controlling things across the facility. And that's what we want to kind of high level break this down in terms of the different buckets. How do you choose? That really becomes the important question here, right? Of when you're walking through your process, you need to understand what is best for you. And where that comes down to is what's best for your facility. So if that's the facility that you're managing, or if that's the facility of your customers that you're helping support, understanding what their needs are becomes the really important question for you. Right? Do they need visibility? Do they need calibration? Do they need local control versus central control? Do they need to be able to view all this information from remote applications, not just directly in front of a device? Do they need the data stored, right? Can they get away with pen and paper, or do they want some more advanced data storage? And then there's a lot of other advanced features, but how simple do they want that covered for their use? So a lot of questions you're going to need to kind of ask, and we'll walk through some of those in this exercise. The first one I like to kind of refer to here, right, is walk the line. So for those of you that have been in facilities in the water industry, this is probably a pretty common term to you. And it's what a lot of operators do. They will walk around their facility and they will simply check all the screens to make sure that the readings are within the specifications that they're looking for. So in this example here, being 7.21, right? Again, this operator is walking past and says, "Yep, that value looks about good," and moves on to the next part of her walk. And that is something that's really important, right? What's the level of visibility that you need? Now, this is a very simple, indicator in this example here. So then the question is, do they want other indication with it? Do you want an alarm present? Do you want to be able to see what that's trending over time as you walk past that? Do you want to be able to understand if a relay is activated, if an alarm is triggered, et cetera? So when you start to think about the level of visibility, it can start to compound out as you add more. But on the other side of it, if you don't have someone walking around and you don't need that, you have your options of like blind transmitters and blind controllers, or sending everything to a central hub, and you don't need to see that information. It's really going to come down to what's the preference for that facility and what works best for them to making sure that everything is maintained on a regular basis. Calibration, right? For those who are more familiar with this in the industry, we all know calibration is a necessary evil, right? We have to perform calibration to keep our sensors up and running on a regular basis. Some places will let that slip a little bit longer, but when you really need important information, making sure that those sensors are calibrated is really critical. One of the things you may want to start to consider with this is simplicity in the calibration. So the example I use here with our 2250 series, it walks a user through exactly how to calibrate, right? You can kind of see in these screenshots, it says put the probe into the first buffer solution. And then it says this buffer solution is probably 4. Continue if you believe that's true. And it moves on to the next, and then it tells you all your information at the end. That to us is simple in the calibration process. And having that right in front of you is really important, right? So it's something that you can walk through makes that simple. Also thinking about it, how do you calibrate in your facility, right? Do you need to walk to a location to perform that calibration, right? With some sensors, they can be hundreds, if not thousands of feet away from the controller. So how do we work through that, right? Today, I'm sure some of you have either done it or experienced it or heard about it, of people shouting the calibration values or radioing it or even writing it down and having to bring it to the device. So when you think about location is really important in terms of how you're operating, where do you put your controller, right? If you can have a controller right nearby that can perform calibration, that may help. Now, it doesn't have to be a controller per se, right? An analyzer can also perform a lot of these same types of functions of performing the calibration directly there and then sending that signal off to where it needs to be, or again, just being a local display. But the key to this really is, how do you make this simple, right? Do you have to unwire your sensor? Can you work on it nearby, et cetera? And that's where you want to start to think about what makes that process really easy, like a walkthrough calibration process. How does that make your operator's life better? And control, right? As we talked about, right, that's the essence to a controller, right? That's going to bring your difference from an indicator or transmitter or just simply an analyzer to a controller. So the first question, right, is how? Well, when it really boils down to, there's kind of two main ways that controllers are interfacing with other items across the facility. Very simple in terms of relays, where you think about that as an open close or an on off. Really simple in its nature. I'm sure a lot of you are very familiar with those. And then you have your output signals. These can be very simple, from 4 to 20 outputs to more complex of Modbus or digital or other types of signals that are being sent out from the controller to tell other parameters what to do. So that's kind of the how behind the scenes. The what, there's a lot of options of what you can control with a controller. Right? You can control your valves. You open and close them based off of reading, right? So if you want to open a valve based off of a high pH, a controller can do that. If you want to indicate an alarm is off, right? So the controller may have a display, but maybe you want to put a light up in that facility and say, if my pH drops below 6, let's have a light up there, let's have an alarm up there, and that will bring someone to come in and perform an immediate action. Again, it comes back to the needs of your facility, how to simplify it. And there's all sorts of other ways you can connect this in: pumps, disinfection, equipment like UV, dosing pumps, and even heaters. Again, you can control all these with controllers. Again, whether it's via relay, it's saying the very simple on or off, or open or close, or you're sending a signal to it and saying, this is the reading you want to send to a dosing pump, and you can tailor that based off of a pH reading. You can say, I want to send this percentage over to the dosing pump, and that dosing pump can feed that in. So again, you can get more complex with it, or you go into your kind of digital readings and say, I want to send this information in so the next device can perform its task as appropriate. Remote capabilities. So again, here we are in a virtual meeting, remote, right? We are living in a very digital age where we need to be more and more connected. Whether or not you really want to be, that helps in the way that facilities are operating and the ability to perform your day-to-day operations within a facility. So remote capabilities become really, really impactful of how to share that information, right? So again, as we talk about that local control, being able to see it is really good. But if you have a person that's sitting inside a control room or a person that is remote, having that information of that pH value is low and that action is needed if I didn't set up a control in there and manual action is required, remote capabilities can be really critical to get there in time so you don't have an issue. And I'm sure a lot of you have experienced losses in either your facility and in some of your customers' facilities, right? We'll use an example in an aquaculture facility, right? If the pH were to drop to 4, those fish are going to die. And that's something they would need to correct for right away to make sure that those fish can survive. And it's the same thing in any different facility. There are critical thresholds on certain parameters that if those parameters fall to those levels or rise to those levels and intervention is not performed, there's critical losses to those facilities. So something like our AM2300 has really a nice intuitive remote capabilities with a display, a graph, alarms, to kind of up to different 16 screens. Again, it's really trying to tell you your information in a simple form so you can be better informed about what you need to do to optimize your facility. Data. Data is key. And I want to explain this one really with a story here. So with this case study example, there was a large health network facility that was really struggling to keep their reports up to date. So they were actually paying a consultant outside a lot of monthly fees. And even with all of that, they still weren't getting the information they really needed on a regular basis. So they were hemorrhaging money and they were struggling to keep up to date with all of their reports. By implementing a controller that performed data logging for them and automated their entire process for them. So they're able to generate these reports on a regular basis and save it and having an outside resource come in and capture all this information. And ultimately, they save thousands of dollars every month by maintaining that compliance internally rather than having to pay for that outside consultant to support them. And this becomes really important when you start to think about it is, again, as we're moving to that more digital age and having all the information at our fingertips, we're starting to move away from the pen and paper days of storing data. Because it's easy to make the wrong note, and it's also easy to lose a piece of paper. Whereas with data, you can have redundancies, you can have backup, and you can store it in central locations. It just simplifies the process when you start to have data, when that's applicable for your types of facility. Right? There are going to be some facilities that say, I still prefer the pen and paper, and for us, we don't need the data. And again, that's where it comes back to that question: what's best for your facility or your customer's facility? Now we get into it in kind of the advanced controls and analysis. There's a lot of stuff here, and this is just starting to scratch the surface of what I think are some of the more used today advanced features. And again, it's really what's needed for you, right? You need an alarm delay, right? Maybe you don't want the alarm to go off because there may be some fluctuation in your process. You don't want let's say it's tied to a buzzer. You don't want a buzzer going off every 5 minutes because everyone's going to get, they're not going to pay as much attention to it if it's going off with false alarms all the time. So having a delay to make sure that it really is going off when it needs to go off can help improve that facility. Cycle features can be really good, right? If you're running a pump on a regular basis, maybe it needs to have a little bit of on and off, so you're not going to damage that pump, by over exerting it. But also, if you think about it from a dosing standpoint, sometimes the point in which you're measuring is further down from the point in which you're dosing, or it takes a little bit more time for mixing to properly occur. So if you're driving a reading, let's say an ORP value, and that ORP value you want to keep above, 300 millivolts, if you're dosing chlorine to get it above there, and it only takes about 5 minutes to dose, but it takes about 60 minutes for it to properly mix, you may want to be cycling it on and off, knowing what some of those parameters are. So that way you're not overdosing, because it's a lot harder to remove the chlorine than it would be to add the chlorine in that instance. Damping is another great feature for those not familiar with it, where again, if you're getting some signals, as you can see here on this graph, they are jumping up and down a little bit. There's some variation. You want to see a nice stable number, right? Maybe your facility likes to see things nice and clean. So instead of something jumping from a pH of 7.21 to 7.23 to 7.25, maybe you want it to be nice and steady and average that out. And dampening can help you with some of that averaging, again, simplifying your view. But again, it can also help with, again, in terms of towards the alarms. If you're able to dampen out, you want to know that it's a trend, not just the one static number. Backup, right? Backup in this day and age is critical. Knowing that you can restore your equipment back to its a desired state without having to reprogramming it all the way through, or also with your data, not losing that data and then able to back that information up. So being able to store information can be really critical in facilities where you need to be operational, right? There are some facilities that people there will know that statistic at their fingertips, how much money is lost for every minute that they're shut down. And there's been a few facilities I know I've been to where that number is in the thousands of dollars per minute that they lose just by being shut down. So being able to restore information is really impactful. Again, moving to access restrictions. Some facilities will want certain people to perform calibration, and they may not want others to perform that said calibration. So some controllers can actually restrict that in, where there's levels of tiering or hierarchy that are implemented into the controller to help facilitate that across the facility. Again, just simplifying what's there in front of you. And the last one, data and AI. This could easily be a whole nother webinar just talking about that. But again, if that's something important to you or that's something your facility is looking at, that's maybe something you want to get with the controller. On the other hand of it, if something like AI and data analysis scares you, you may not want that into a controller right away, because you may want to be looking, again, for that simplicity in your facility. The one I want to flag here, again, it's a bit of an advanced feature, but it's something that we like in our 2300, is what we refer to here as virtual sensors. So a lot of times you have a sensor that gives you one piece of information, but you want more from it. So maybe it's a flow sensor and it's telling you what the current flow is. And that's all well and good. But what about what was the total flow over the course of the day? That information can be really important, right? If you're thinking about, is a tank filled or is it going to overflow? Knowing what the total amount of flow is can be really important. So if you want to see both the flow and the total flow over the course of that period of time, having a virtual sensor allows you to use one sensor and two outputs on your display. Or you can do other items here, like as I show in this picture, where you can actually look at what the chlorine level is from a sensor and then what the pH is, and you can then have your adjusted chlorine based off of the current pH value as well. As we know, chlorine is highly dependent off of the pH for how effective the chlorine level is at that current time. So being able to perform that all within one controller can be really important. What it all really boils down to, though, is what's the ROI for your solution, right? As I talked about, there's a lot of different features, and some of these features may not be really important for you. Right? You may be paying extra for some of these features, and you may just not simply need them. And that's where it comes back to when you think about the array of different options of indicators, transmitters, analyzers, and controllers. an indicator may be the right item for you, because when you look at it in contrast, an indicator is always going to be cheaper than a controller, right? There's a lot more function in that controller, and you're paying for that function. But if you don't need those types of functions, where it comes back into is what is the ROI you're getting. So there was a good example we have here with a really big aquaculture facility. They were struggling to be able to see all this information across their different facilities and maintain the proper parameters. And that's where they really looked at and said, we need remote capabilities, and we need a site-wide ability to see the information at different facilities at different times, so we can make sure people are responding in appropriate fashion as they were sharing resources across these facilities. They also needed to ensure that there was data from a compliance standpoint to make sure, again, the fish were in the right environment throughout the course of their lives. So having that solution, these were areas where they were losing money on a regular basis in terms of not being able to operate as efficiently. And by implementing some of these solutions, they were able to calculate an ROI of less than 2 years, where they were actually at that point then breaking even and starting to make money moving forward. And again, simplicity can really lead to it. So we have a great kind of example here where someone looked at this, and this is an example here with our 2250 controllers, which again are not as robust in terms of the features. They're just as robust in terms of their competency of the 2300. So right, again, feature rich versus strength in its ability to perform control, right? The reliability is what was really important to this customer here, but they didn't need all the bells and whistles of something like a 2300, and this worked exactly for them. And what we love, with this one is they haven't had a single failure as they started to implement these solutions into their market. So again, it's reliable. Reliability can be really, really important. So again, as we've talked about features are all well and good, but when it comes down to criticality, reliability can be one of the most important items when picking the right solution for you. Also, that it needs to be easy to use, right? You have to be able to continue to use it, and your team and your supporting team will need to be able to use that as you move forward. And that all comes down to, is it simple for someone to be able to understand and be able to use? As you get more complex with controllers, especially as you get into PLCs, you get into this environment where not everyone knows how to operate them. So we talked a lot about this, and now going into the simplified Aquametrix solutions. As mentioned, controllers can do a lot. And as you see here, there's a lot of things that the 2300 can do. And I won't go into all the details with this, but I want this to kind of make you start to think of the question, what's the level of control that you need or your customer needs? Because again, there's a lot of features that can be used here. And again, as you start to think about it, what's the main driver for that facility, and how do you give them the best ROI for what they need? So we look at it from this type of point of view. Within our portfolio, we have our end of our transmitter, our 2250TX, moving up to our analyzer/controllers with the 2250 and 2252s, where again, the core of these is being able to provide the information, the local display, the local control, and the simplified calibration. And then you have your 2300, as I showed, with a lot of the features where it is really feature rich and can perform a lot of the functions for you, again, simplifying operations at different facilities. If you look at the 2250 series itself, this is really great, for putting it inside a PLC. So we have a lot of installs where the 2250 is put inside a PLC because, again, they want to simplify calibration. So they want the calibration done on the 2250 series rather than done with the PLC programming logic. So then it, again, simplifies it for that individual and can be then a drop-in replacement for adding new controllers into that place. And again, making it really easy for them to use and be reliable throughout the entire process. Where again, looking at the 2300, a lot of different features that makes it really feature rich. And this, where we look at it, is really good for those small to medium-sized and growing facilities where they're looking to do more, they're looking to learn from their data, and they're looking to optimize their facilities. And they also want to have more access to their information on a regular basis. Or I want to kind of conclude it again with, to me, what is the most important, right, is reliability and life. So we have some installations of our controllers and transmitters that are 10 years and counting. And that really stands with our core value proposition, right? Of when our controllers work when you need them to. And that is so important today in this industry, right? That if a controller shuts down or analyzer shuts down, people don't have the ability to see what the values are, and they just simply don't know if things are working as they're intending to work. So with that, I covered a little bit of the high level of what we're looking at today in the landscape. And again, there's a lot more you can learn about controllers and analyzers and the different functions and features with it. And that's where I want to flag, our great sales team, right? So our sales team is very knowledgeable about our products here, and they're knowledgeable about the products in the industry as well. And they're here to help you. So feel free to always reach out to the sales team or scan the QR code and look more on our website to learn more information about our products and what we have there. Our team is always more than happy to talk about all the different options there. And really what it comes down to, as I noted before, we'll be asking you questions about what is it that you guys really need and looking for what is the right solution to fill those needs for you and your customers. So with that being said, I'll open it up to a question and answer session here. If anyone does need to drop, I appreciate you joining at this point. But if anyone has any questions, feel free to add them into the Q&A portal. All right, so I see a question here. Can a controller replace a SCADA system? It's a good question, and it really comes down to it depends. So it depends, again, on what the level of control you want, the level of redundancy, the level of visualization you may want at that facility, and what the level of complexity across the facility. So there are some instances where facilities won't have a SCADA system because the controller does everything they need for them to be able to operate effectively. Someone asked, what do you mean by a blind transmitter? So yeah, a blind transmitter, for those that might not know, used fairly common, so it could be a blind transmitter, blind analyzer, could even have a blind controller. Basically what that means is you're just not having a visual display on the device itself. So it's performing all the actions behind the scenes. The only way you'll be able to see how it's kind of operating is you tie into its operating system behind the scenes, which again would be different from controller to controller. But essentially a blind one, makes it a little bit simpler for some operators where they don't need to see it, right? They might not be doing the walk the line. They just simply want it to perform its actions and move on. A lot of times that really comes down to a cost reduction option of displays versus no displays tend to be more expensive. Well, that's it then for the questions here. So I appreciate all of you joining on the call today, and please do reach out to any of us if you want to learn more. Again, this is something that excites all of us, and we're always happy to talk more about analyzers, controllers, and transmitters. And really, it's all in the name of how to make water quality as best as possible, and knowing that you need more than just measurement. You need to implement control as well to achieve optimal water quality. So again, thank you all for joining today, and have a great rest of your day. Thank you.